I thought he'd get here and have his pencil case. I was like, oh, it's okay.
But then I opened my bag and there's no pencil case anywhere. I don't even remember removing it from my bag.
I looked yesterday how he asked you why you hadn't emailed about academics. That's what's it called? The module rep. He was like, I was going to, but I went to sleep. And he was just like,
so disappointed.
I did send him a message.
did you email him?
Yeah.
Very good. Okay. Well,
You're
module
carrying
rep.
the class at this point with that.
That's
so.
true.
I don't even know what I do. It's the first time.
You're going to ask to be paid. You should ask to be paid.
You don't have to represent all four of us. Well, three of us, right?
I said that I'm setting up for module research. My qualifications are that I'm studying monetary. He accepted that.
Either thinks you're really funny or really autistic.
I thought it was really funny when I read it.
Just commodities essays rather than saying that. As I told you doing it, I've realised I'm doing a bunch of stuff without actually doing the methods. I've moved on to that formally. Like I've done it already, but formally did the writing, and now it's all just falling into place. But I've so found it. It's been
What's
like,
your project?
I just did it on copper, and then I did it.
I don't know the copy.
It's very descriptive because I think it's really good.
It was copper prices and then comparing that to the exchange rate between the DRC and China. That was a pain in the ass. What are you doing? You're doing copper.
I'm doing a very basic customer relationship kind of thing on the global supply and demand, calculate the excess production. I'm just doing it very simply on that. So I don't think I actually want very much for it. It's not just play around with stuff like that. So we'll see how it goes.
Are you doing any, like, how are you doing supply and demand at the same time? Are you like sort of...
So I found on Refinitiv the global production and global consumption, which I think is slightly better than import and export.
Yeah. I'm just not throwing you into your works, but I think technically the quantities for consumption and production are they come out or observed. It's simultaneous basically. So you have to have maybe I think just some sorts to control the simultaneity.
How big with this descriptive one? Because I emailed about him about it. He literally said it's just you say a movement, you relate that to the model, say the price moving results of it. It's very basic. I was surprised at how simple he wanted it to be. So I'm just doing what he said at this point. See how it goes.
When he wants to, that's it.
Yeah, exactly. I thought it was suspiciously basic, but you know, I'm not going to argue. I'll do it.
I don't know. I did it first. I didn't do it. It was interesting.
Very good. Very good.
Yeah, no, really good. I talked about small super light borders on countries and give them really long information that actually answer what I was asking. So half the time when you people they don't really understand what you're asking because either you've worded it in a way or that you've worded it in a way that's like something like that. And they just assume it's that. So what you're actually asking. Yeah. No, you're wrong.
It's best for you to say, see lecture slide.
Oh, that's I didn't say that like
Including yesterday's if you'd like it.
That's my supervisor for master's personal statement tips. And I got like I said, big list of questions I had. And I got back I thought at the end I'd be answering your own and just like, okay. I'm still not heard back.
Sorry, we started a bit late. But, Okay, so what we saw yesterday was I started on our first proper model of money, so to speak. It's the Grau Yunus model. The motivation, it's a very simple structure. The motivation is that you will hold money because, motivation for holding money, because there's a transactions constraint. Okay? The goods that you wish to sell, against which you will buy goods, the revenue that you earn from selling those goods might not be available immediately. It seems to be quite a realistic way of doing it. Called cash in advance constraint. It's not very easy to work with, but this is a model in which, in terms of the results we get, it's all right, it's manageable. Okay. And we set up the problem formally. I wrote the first order conditions on the board, telling you that we will be deriving them on the problem set, which I hope you will do. And then what we saw was, I wanted to write all that again, but once you impose stationarity of the equilibrium, which is to say, consumption will remain constant across time. That's the key problem. And with a constant money supply, that would mean that since what you are trading is the same amount every period, you would expect prices also to be constant. So in that framework, what we saw was that the first order conditions thereby tell you that the marginal utility of consumption, which has one factor, which is the discount, and the other, which is the derivative of the utility, period utility, it keeps changing by the factor beta. Because of which you're able to say that the sum of the two multipliers, the lambda and the pi that we had, that also keeps changing by beta every period. Because of which we were able to get the implication that, in fact, the Euler inequality took the form which is another way of saying it's the first order condition that determines whether you're holding the optimal amount of money. So it took the form lambda it greater than beta I plus pi I. The reason being, what we actually had earlier was lambda it plus 1 plus pi it plus 1, but that gets replaced by beta I times lambda it pi it using the first order condition for the amount of good, of each good that you will carry. Okay? And both of these are either strictly positive or negative. Okay? And of course, this is with equality if MIT is strictly positive. And therefore, this tells you that since at equilibrium, right here, stationary monetary equilibrium, MIT is positive for some I, right? This is a positive amount of money, someone must be holding that money at each day. Okay, it could be a different person. In a stationary monetary equilibrium, you could expect it to be the same person. Both could be holding positive amounts of money, but at least one person will have a positive amount of money that they're carrying, and therefore for that person, for that I, what will you get? Well, you will get equality there. For that I, since beta is in 0, 1, pi I t must be strictly positive. Okay, that follows. You should convince yourself about that. Put in an equality there, right? And once you do that, you see that if beta I is strictly between 0 and 1, even be 0, but we don't want to consider that case, it is the case that pi I t must be positive. Otherwise, the equation cannot hold. Is it okay? Clear, everybody? So if you are holding money in such an economy, you are doing it because your cash constraint binds. Why? Because holding money means that you pay the cost of reducing consumption today, being able to consume tomorrow. But if you do that, you have to discount. The fact that you discount, you care less about tomorrow than today, tells you that there will be a cost to holding money. That's basically what's happening. That's the interpretation. Is that okay? Clear? Yeah? You don't seem to be convinced, Tim. You don't seem to be convinced. Or are you okay? There's something that's going wrong. This is crucial. You proceed from here. Next step. But we want to make sure that this one's in place.
Seems fine.
Seems fine? Okay, good. All right. So now we go to efficiency. Okay, now that we know that, we go to efficiency. So there is a monetary equilibrium allocation Pareto optimum. Right? So remember, when we spoke about Pareto optimality, we did it in different ways. I gave a formal definition, etc. But if you go back to the Edgeworth box, the idea is you should get a tangency. The marginal rates of substitution should be equalized. If you get that, you have Pareto optimality. If you don't have tangency, you take it for granted that you can make an improvement. Okay, those are local properties, but that's all right. That's one way of doing things, and that's fine. So over here, let's look at the marginal rate of substitution. So how are we going to do that? So for A, is marginal utility. That's A's beta t partial u. A is a bit of a mess to write. Partial x l. I'm going to call the first good now. At A's equilibrium consumption. Okay, which from the first order condition, so I'm going to write it on that side without putting in anything in the middle. Okay, I'm going to take a ratio here. So on the right, I'm going to get P1 star. You can check what you had yesterday. Lambda AT, right? Very certain I am. I do not want to write something that might not be. Yeah. Okay. Now, what comes next depends on whether or not we include the factor K. We will include the factor K when A is selling the good. So over here, we're going to assume, and this is without loss of generality, assume A buys good one. Okay? If A buys good one, then over here I get lambda A T plus pi AT. And I'm going to get beta T A is marginal utility from consuming the second good, which over here A will be selling. Is that okay? So if A is selling that good, then I will get P star 2 lambda A T plus K by AT. Do we agree? That's the marginal rate of substitution? Yeah? So these are equal. Is that okay? But now you notice that this will exceed P1 star divided by P2 star by A. T is positive, okay, since K is positive. Is it okay? All right? Make sure that you understand this. Because if K equals 1, right, then these two factors will cancel out, the bracketed terms. If K is less than 1, then the denominator is smaller, and therefore it will be larger than K1 star. Okay? Of course, you could do something similar for P. Okay, I'm not writing the term out, you have it in the notes. The equivalent for B will be equal to something equivalent for B, but B over here is buying good 2. So it's P1 star divided, sorry, P star 1 divided by P star 2 if I, B, and D. But at least one of these two has to be positive because we are in a monetary equilibrium. Right? We said that earlier. Pi has to be positive for one of the two people. It could be positive for both. So at least for one of the two people, you will have their marginal rate of substitution exceeds or is smaller than the price level, and therefore the two marginal rates of substitution cannot be equal. I'm not right. Is it okay? Is the argument clear? Completely clear? You see how simple this is? Of course, you're working with things that you don't really see. You're working with marginal rate substitution you're familiar with. But you're working with multipliers that have come all of a sudden from nowhere. Okay? But you really can't do it without that. Without that, you'll be waffling. And I'll give you the waffling argument in a moment. Yeah?
So because they're buying and selling the opposite side of the trade, the prices must be the same.
Correct. And the price is given to you in equilibrium. The price is the same for both.
Right.
That's the key point. Money, the fact that it's costly to hold money because you discount, means that your marginal rates of substitution do not necessarily equate the price ratio. If you are holding money, it will not equate the price ratio. And therefore the marginal rates of substitution themselves will not be equal. Rate optimality has got nothing to do with prices, remember that. Rate optimality is about allocation of resources. The fact that in a competitive equilibrium you get rate optimality is a result. That's the first welfare theorem. But that fails here. That's what we've shown so far. Is it okay? Yeah?
This is okay, a bit trickier with multiple people, like beyond two.
It doesn't matter. I need to show this too. You can do it for, you see, suppose you have many goods, many people, it doesn't matter. Take any two goods. The key factor is this one.
Right.
In equilibrium, somebody's pi has to be positive. So long as I get that, I take any pair of people, okay, and any pair of goods, I can do something very similar. I get that inequality, or that one, for one of the two people, and you're done. That's all that I need. It could be true more generally. It could be that there are whole bunches of people who are very unhappy. But for showing that it's not Pareto optimal, it suffices that I can find two. One who's probably happy, the other who isn't. Okay? And I put them together and make a trade. Is that all right? Yeah? So the cash in advance constraint is creating a wedge, which is a very popular term in economics nowadays. It's useful. You get a paper published, you need the word wedge in it. But it actually appeared a long time back in the literature. You know, it's full of this term. But that's exactly what's happening. Price ratio that you see in the market and the marginal rate of substitution that you use in your optimization problem are not the same. It's not to say that you're not optimizing. Never make that mistake. Okay? That's the first order condition, the one that we have here on top or on the bottom. That's what you need for optimization. But that does not mean that it's equal to the price ratio. Because that will happen when the pies is 0. But here the pies will not be 0 again. You are holding money for a reason. You would be better off if your cash constraint were to be stagnant. That's what's happening. Is it okay? Yeah? So, this is very generally true here. It just very generally says it's always true. Unless your endowment is Pareto optimal, you don't trade, that's a separate matter. So long as there is trade, somebody will carry money in equilibrium, that will happen, that will happen. You're done. So you start by observing that introducing money into the economy could be nice. You have very good reasons for doing it, but it doesn't solve your problem. It will make allocation of resources better than it was at the endowment. This is probably true, particularly in simple economies. In a simple economy, if you are at an endowment and you have the option to trade, you will be better off. This is clear, because staying at the endowment is an option that you always have. Okay? But in more complicated economies, even that I should be careful. With the endowment structure, it's always true. So long as the endowment is feasible, it's in your budget set, that's always true. So if you're able to stay with your endowment and you prefer to trade, you must be better off to that extent. Okay? This is no longer true when you start looking at things called second best interventions, but we're not looking at that here. Okay. Now, one minor observation, if beta equals 1 is allowed, then of course you're patient. If you're patient, then you don't really care whether you consume today or tomorrow. And if you're patient, over there, once you have equality, y is 0. So if you're patient, it's all right. But you really don't want to look at an economy in which these things are costless. Typically there is a cost. Is that okay? So even that bit, although it's true, doesn't really get us very far. All right. So now we want to ask, what about monetary policy? Can we do something simple in this relatively simple setup? Who says something about that? The question actually comes from some work. This is traditional, but formalized by Milton Friedman. Milton Friedman said, look, it's true that people will try to save on the amount of money they carry. This is basically what they're doing here. Because the discount, there's a cost to holding money, so they save on the amount of money they carry. But the government produces fiat money costlessly. So why not compensate them for their discount by paying them a little bit of interest? How much interest? Well, the answer is, in this simple model, you can actually calculate the amount of interest. But the bigger problem is, if you get it wrong, what might happen? You have to get it exactly right. And we'll see. That basically means everybody must have the same discount rate. Yeah, that follows from the first order condition setting. But we need to set it up separately, so we need to move to a slightly more general framework. Okay? So, a more general setup. Before I proceed, I should ask you, finding this interesting? Is it too difficult? Manageable so far? Yeah? All right, yeah. Right. Not to be done on your own. Nobody would want to, or even you would find it difficult to figure out where to start. But if you helped along, hopefully, this is the point of view that I've always held about the classes that I teach. That third year undergraduate students who are willing to learn can learn this activity. It's not that they cannot. Okay, but of course, you have to put in your bit while I put in mine. Okay, so what we are going to do is we are going to include a nominal tax or transfer. So the money supply will change over time in a very simple way. Okay, there's no central bank here. We don't have bonds here, government bonds. There's no government, so you cannot really have open market operations or anything like that. This is a model of what's called helicopter drop money. Okay, so you just endowed with certain amounts of money, which is central bank can give. Not too bad as a starting point. Although it's widely derided by people on television, but it's really not realistic. It's not meant to be. Otherwise, it would not be called helicopter drop. Okay, it's just telling you how to think about things. So, AIT is a nominal tax or transfer, and it's specified in this very special form. So alpha is a parameter. Alpha will be the rate at which the money supply changes, and we'll see that in a moment. Okay, theta I, okay, is the distribution of transfers greater than or equal to 0, and the sum over I of theta I equals 1. So it tells you how much of this change in the money supply, which is what you have on the right here without the theta, is going to affect each person in the equation. We have two people, so there are basically two numbers that are non-negative and add up to 1. Okay? It does not change over time. We're keeping things simple. It's not as though all of a sudden you decide to give more to Mr. A. Proportionately, you give them the same amounts. Okay? Proportionately, in terms of the thetas. So now, m at t plus 1 will be equal to, well, m at t plus whatever the transfer is to the different people, okay, at t plus 1, so the timing convention just makes sure that things work out nicely, which is equal to mt plus what we have there, since theta adds up to 1, alpha t, alpha t plus 1, say t plus 1, alpha t plus 1, alpha minus 1 times M, and this you can check that this is solved by setting MT equals MT, not MT plus 1, MT equals alpha t plus 1 times M, and we're going to keep alpha between 0 and 1. Alpha is the gross rate of change. So what we are doing is we're basically going to remove money from the system. You might ask what happens if you increase the money supply. You'll see it's easy to work. That's the wrong direction in which we go. Yeah.
Sorry, the
Let's
difference
go.
between M and MT is in the MT plus 1.
Sorry?
The difference between like M, MT, and MT plus 1.
Yeah. So the idea is here you describe how the money supply will change over time.
Yeah.
And we are saying that a solution to that difference equation is given by setting MT to be some constant M, which is positive, times the rate of growth.
Right.
That's it. Okay? So, prices will also be stationary. Because we are looking at a stationary solution in consumption, so prices will also be stationary. And will be given by P star T equals alpha T plus 1 P star. Everything that we did earlier is a particular case for alpha equal 1. Okay? So, over here, no transfers will be made, etc. It's just we're allowing alpha to be larger or less than 1. Less than 1 case is the more relevant one. Larger than 1 is covered. Okay? So now, my optimization problem. I'm not going to write all of it out. Okay, but maximize, well, by choosing, what we choose is there in your handouts. I'm not writing that, right? So it's the amount of the good that you consume in each period and the amount of money that you will hold at each date in order to maximize your discounted utility. T0 to infinity, beta IT, UI, xit, subject to, well, mi minus 1 greater than or equal to 0 given, and then xit greater than or equal to 0, MIT greater than or equal to 0. So what we saw yesterday for all t. That's a symbol that I might not have used on the board, but that's for all. And then my prices, well, prices will take that specific form. So I'm going to write it with P star, because even at equilibrium, I'll be solving the same problem. Okay? And then the form in which we have the spot market price plus MIT less than or equal to alpha t plus 1 P star omega I plus MI t minus 1. And now I need to make sure that I include my tax and transfer, which is plus AIT. Again for all t. And then I have my cash constraint, which is alpha t plus 1 P star dot. Okay, so this is the whole thing together is my price at time t plus 1. In particular, we're looking at what will turn out to be a stationary equilibrium. For the moment, we're writing it in that form. xit minus omega I plus less than or equal to k times alpha t plus 1 P star xit minus omega I minus, and then over here I will have plus the amount of money that I carried from the previous period plus any transfer that I received or tax that I paid. And again, this is floating. Okay, so that's the problem. And an equilibrium here. Stationary equilibrium. Well, you would want that to be true. That's a vector, the two goods. You would also want your money demand to be equal to the money supply at time t. Okay, but given the structure of the problem, at stationary prices, your money demand also takes a special form. MIT will be equal to alpha E plus 1, some constant. Right? All the nominal variables should increase at the same rate. This is what you would expect. We are not proving it, but there's some things that we can sort of say is all right. For all t, with at the initial date, mi minus 1 will be equal to this mi star value, which is positive, okay, greater than or equal to, in case someone does not need to carry money. Okay, and therefore if you substitute that in together with the structure for m, what you get is you can cancel out the alphas on the two sides, so your equilibrium condition for money will actually be some mi star equals capital M. So the money demand and the money supply are growing at the same rate, so you can cancel out essentially the rate factor. Okay? Okay so far? Now, lump sum taxes and transfers are in a sense very nice. Why? So I don't know how much you've seen of taxes and things, but essentially, if you what you are worried about when you tax, and you almost always have to do this, which is why public finance and theory of taxation is interesting, is when you tax, you affect the price ratio that the person faces. Okay, so those are distortionary taxes. Most taxes are in the category of distortionary taxes. We don't like to distort exactly because of some argument that's similar to that. Because if you distort, then marginal rates of substitution, you'll be talking about production economies, so marginal rates of transformation will not be equalized. So you want to minimize that to the extent that you're able to, which is why we use lump sum taxes when we are able to. So lump sum taxes will simply move your budget set without affecting the relative difference. So that they do not distort. That's the nice thing about it. But they are a complete pain to work with because they move the budget set, the entire budget set. Right? So the better way to solve these problems, if you're able to, is to restate the problem in a manner that will avoid the need, or that will replicate what you wish to do without changing the budget set. So we're going to do that here. Okay, so we're going to transform the problem. So, now you have to do this a bit carefully, but for the purpose of what we have in mind, the key idea is divide all your constraints by alpha t plus 1. In some sense, it's a homogeneity property. You say it shouldn't really matter. And what we want to know is how should you fix the tax transfer policy so that you get back to the original problem, an equivalent problem. Okay, so I'm going to do that roughly on the board. So if you divide through, so here you divide by alpha t plus 1. This is a choice variable. You divide by alpha t plus 1, divide by alpha t plus 1. Since I'm out of space, mark it as though I'm dividing both by alpha t plus 1. And similarly over here. Okay? Now, some of this isn't too bad. So instead of the A's that I had, I would get, so I had AI t plus 1 equals alpha t plus 1 alpha minus 1 theta I m. Okay? So I want to divide that by something I'm doing.
Can you not get the AIT with alpha t plus 1 by expanding the bracket first?
Just a moment. No, there's something here. You see, I look at this each time I teach. Every time I teach this class, there's something or the other which when I look at before I teach the class, I think that's wrong. And then I think about it again, I think it's fine. I figure it out. But always on the board, I get stuck on something or the other. So I want to make sure what I'm saying is correct. There's an extra alpha term that I have here. I should know.
It says divided period T constraints, so we not divided T plus 1.
Divide the period t constrained by alpha t plus 1. That's correct. That's exactly what we are doing. Now, what I want to make sure, but I have AI, it's AIT here, correct? That's one. It's AIT, and AIT is specified as, what is it? AIT is specified with alpha t, correct? Okay? Yeah, so if that's what you're saying, then thank you. Divided by alpha t plus 1, alpha t plus 1. So we get alpha minus 1 divided by alpha theta I times n, and this I'm going to define. Okay? That's my new tax transfer, and it's independent of time. It's a constant. Okay, so if you ignore the theta I, because that's just shared, what it's saying is that the money that you carry, here it's in terms of the money supply, which its base rate remains constant here, right? So that's what you have, and what you have, so your money demand, which is the MIT minus 1 here, which also needs to be adjusted, together with this tax transfer that you're getting. So the tax transfer, it's a constant payment that you're receiving, but it's as though, okay, so the factor on the constant payment is 1 minus 1 over alpha. Okay? So that's going to be, it's going to show up as an interest rate. You'll see that in just a moment. So that's for the alpha. And then for the M, you have MIT in equilibrium with the standard budget constraints that we set up earlier, was increasing at the rate alpha with a base value of MI star. Okay, that's what you had. So now what you're going to get is you will have a new choice variable which will capture the one that you have here divided through by alpha t plus 1. Now what does it do to the previous period? In the previous period, again, you would have the choice variable from the previous period, but it's divided by alpha t plus 1. But your new variable will be in terms of alpha t times alpha. Okay? So what we are going to, so I'm going to write it out the following way. Your budget constraints will become, okay, so so the budget constraint and the cash constraint, so this, right, this constraints become. Constraints become, so you will have P star xit plus n prime it. This is a choice variable. But what it reflects is that one. What you had earlier divided by alpha t plus 1. And the earlier one in equilibrium was increasing at the rate alpha t plus 1. So the m star I that you pick up will essentially be the same one. Try and see if you can follow this. Less than or equal to P star omega I plus these two, of which the first one will be, since it's from the previous period, you will have n prime I t minus 1, but then you have to divide it by an alpha term that remains, right? Because this is the new variable. It's as if n prime it equals mit, because I've divided everything through by alpha t plus 1. It's as if it's there. And therefore, the one that you bring from the previous date, in terms of the prime value, it should be mit minus 1 divided by alpha to the t. But I'm dividing through by alpha t plus 1, so I carry an extra term. An alpha term remains. Plus the one that I had before, which is a prime I. Okay, again for all t. And then for the cash constraint, I get P star xit minus omega I plus less than or equal to a times P star xit minus omega I minus plus the two terms that I've just written, these two. These are my new budget constraints. And these don't change over time. Is that okay? Right? Now, let's interpret this last bit here. Let me write it here. So, 1 over alpha m prime I t minus 1, okay? This is by how much any money that you carried over from the previous period increases or decreases by. That's the factor. But that's a gross factor. So you can think of it as 1 plus a net interest rate of 1 over alpha minus 1 times m prime I t minus 1. Remember, I said you can think of alpha being larger than 1, but you want to think of alpha being less than 1. That's the relevant case. So alpha less than 1 tells you that this term within brackets is positive. So the fact that you discount is costly for you. So you're encouraged to hold money by paying interest on it. Is it okay? That's what you have here. So that's the gross rate, which gives you 1 over alpha, which exceeds 1 since alpha is less than 1. The net rate of interest is exactly that. And that's what we also had earlier, but that's okay. So you're doing exactly what Friedman suggested. Setting it up this way will allow you to replicate the experiment or the exercise that Friedman suggested. Now, this is a problem. Once you framed it in this form, it's much easier to work out the first order conditions. It's exactly what you did earlier. Of course, instead of just beta I, you will get beta I together with some term in the form of alpha. Together. So once you're able to write down the budget constraints in this form, you should be able to proceed, provided you're able to work out what you did yesterday. And again, on exams, etc., I'm not going to ask you to write these down on your own today. I will give you the problem so that you're able to write it out. Okay? It's not as though you have to. So, memorizing the details of whether it's alpha t plus 1 or alpha t or alpha t, that is not what I want you to do. That's the easy part. That you can figure out. Okay? It's what is around it. How do you work it out? Those are the things that I want you to learn and understand. Is it all right? Okay so far? So when you do that, so now we need to remember what we got here. The argument here was just in terms of marginal rates of substitution. So long as you work with a stationary solution, which is what we are going to do, all this remains the same. Okay? It's just the first order condition will be slightly different, which will affect what you get in the numerator and denominator, and the rest of the argument is the same. So, what you will get is the following. Okay, so solving the Lagrangian. Setting up what you will find is you get the first order condition that lambda I t has to be greater than or equal to beta I divided by alpha lambda I t plus phi I t with equality if MIT is positive, MIT or MIT prime. Is that okay? This you can easily check that this is what we get. It's alpha is compensating for the discount. Okay, I'm going to go over this again next week. However, since we have a couple of minutes and it actually, we've done all the hard work, so it doesn't take very much to tell you what's going to happen. So there will be 3 cases. You need to start by saying that all the beta i's are the same. That's your strong condition. What happens if the beta i's are not the same? Well, you can think about it and we can talk about it next Monday. But if the beta i's are all the same, if alpha equals that common value for beta, then everything's fine. So if you change the money supply in a manner that's perfectly keyed in with the common rate of discount, then you can make sure that you're compensating people for the cost of holding money, and the economy will move to a situation in which as if there is no money. Okay? The use of money is being encouraged. Take it to the point at which effectively you just change the multiplier for each agent on their cash constraint to be exactly 0. Bit of engineering. All very well. It actually might make sense in a Chicago world, which is very simple. There's one chap, nice and rational, etc., etc. Who knows? But that's reality. If instead your alphas are equal to 1, as we started with, or any alpha which is not sufficiently small, you will continue to have the problem that we faced earlier. It should be clear from here. If this inequality leads to a value for pi which is positive for any agent, you will continue to get inefficiency. Okay? So efficiency is something that's very special in the sense that you will get it provided all the betas are the same and alpha set equal to that normal value. What happens if alpha is too small? Question for all of you. Suppose all the betas are equal to 3/4, but the alpha is set equal to 1/2. It's some very keen central banker. What will happen? Think through it, that's all. So, I'll help you a little bit. Look at an agent who's carrying a positive counter. Yes? For that agent, you will get an equality here. And for that agent, with an equality there, we are saying that that agent's beta is larger than alpha. Alpha is very small. So what will be the implication? What must pi be? When in trouble, take some numbers. Suppose lambda is 1. Beta is 3/4. Alpha is 1/2. And you have an equality there. What must pi be? Is it positive? Is it positive or is it negative? So, example. I know it's the end of the class. You're all tired. 1 equals 3/4. Put a question mark there. Because otherwise you would say, or someone would say, I was lying in class. Huh?
Negative.
Very good. This will have to be negative. Which it can't be. It's a Lagrange multiplier. So what we have shown is that if alpha is too small, you don't have a solution. That's what we've shown.